Okay, good afternoon everyone.
Good afternoon.
Have a seat. Okay, let's continue with our topic on integration. Sorry, hang on.
Joshua, you missed the test the other day, right? Could I see you tomorrow after school about 2 o'clock? And if you need also. Thank you.
Okay, so anyway, sorry. Yesterday we talked about integration a little. Okay, we learned a bit on how to go about integrating when we have a power. So our understanding remains that integration is the reverse of differentiation. We were looking at trying to okay, so let's look at how we go about integrating a function like this, where we want to integrate cube root of x. Okay, so in such a case, we want it to always be in the x to the power of something form. So we change it into x to the power 1/3 dx. Okay, so that means that we'll have our x power plus 1. Okay, take that entire power, bring it down to the denominator. Then don't forget to plus c. So in this case, we got x to the power of 4/3 over 4/3 plus c. Okay. We definitely have to simplify this because we can't have a fraction in the denominator itself. So when we simplify it, we will get 3x to the power of 4/3 over 4. Okay. Right, so what we're saying in try 2 is that regardless of whether x to the power of, okay, whatever this power is, right, if it is negative, so negative 4, okay, if we have our rational number, okay, our power rule is able to apply, okay, however, if our power here is a negative 1, then it doesn't apply. I'll talk more about it in the later part of the chapter, okay. Next, we look at trying to integrate 5 over square root x. Okay, so something slightly different. We now have some constant numbers in this case. So in part A, if I want to integrate 5 over square root x, I can rewrite this as 5 times x to the power negative half dx. Okay, so just like our differentiation, we could take out the constant number and just focus on differentiating the function itself. So in this case, when it comes to integration, we can kind of ignore the 5. Okay, so meaning to say, thinking about it in this manner. So we can take out the 5, okay, and we focus on integrating x to the power negative half. And we will know how to go about doing that using our power rule, which is that we get 5 x to the power of negative half plus 1 over negative half plus 1 plus c. Okay. So this refers to 5 times the integration. So the integration here gives us this. Of course, if you are more skilled in it already, you need not go about doing the plus 1 thing. You could do your mental calculation or press it into your calculator. So we are looking at 5 x to the power of half over half plus c. So 5 to the power of half over half will become 2x to the power of half plus c. You can choose to expand this. We get 10 square root x plus 5c. Okay, 5c is a constant itself. You can also re-express it into a constant, another constant d. Okay, so this is possible too. Okay, Yeah.
Why do you have to multiply the 5 inwards?
Why do I have to multiply the 5 inwards?
Isn't it just 5 integral of
Find integral of what?
5 into 2x then outside.
But I have my brackets outside like that. This is the integration of this part over here. So it's a multiplication of this entire thing. Yeah. Okay. Okay. Any questions? Yes. Sorry, I can't hear you. Can we leave it at 5c? Yes, you can leave it as 5c. Nothing wrong with it. Okay. There are many ways when it comes to a constant. We are not trying to find the constant's value itself. Okay. So there are many ways that you could do this. Okay. Since you're looking at integration of this, in fact, if you like to, okay, you could also consider just 5x to the power of half over half plus c outside also can. Just that this c will no longer be the same as this c. Okay? So, but then you must still have the plus constant number lah. Okay? So you must have this plus c idea. Okay? So you will not be penalized if you write it this way or you write it this way. Why am I choosing to write it this way now? Because we're just starting out. Okay? So the integration here technically gives us this. Okay, so that's why I'm trying to keep to the algebraic rules here. Okay. Alright. Any questions? Okay. Let's look at part B. Yes, any question? Okay, part B, we want to integrate the constant number 2 over 3x. If you recall, okay, when under what circumstances will we be differentiating such that we will only be getting a constant number? Okay, it is only when things, for example, we have 2x. If I were to differentiate 2x, I will be left with 2, right? So therefore, when we look at integration, okay, strictly speaking, you can think about it as though it is x to the power of 0, because x to the power of 0 is 1. So if you want to go strictly by the rule, we are looking at having the power plus 1 over 1. Okay, then plus c. So then we have 2x over 3 plus c. Okay, but this is really going through the thorough steps. Okay, you could just recognize the integration of a constant number will give you 2/3 with the x appearing plus c. That's all. Okay, so these steps are actually not quite necessary, right? I am just trying to explain the whole process and science, or rather the maths behind it. Okay. Okay. Next, we look at triform, where we want to integrate these functions. When it comes to integration, we do not have a product rule, we do not have a quotient rule. Okay, so our rules, technically it seems like there are simpler, lesser rules, okay, but there is still some thinking behind that we need to do. So, looking at this, when we want to integrate negative x squared plus x dx, we could look at it term by term. So we can integrate negative x squared first, followed by plus integration of x dx. So we are thinking about it in this manner. Okay, our power rule then apply. So power plus 1 divide by that power after adding 1, followed by integration of x is x squared over 2. Okay. Notice that I didn't put in the plus c for each integral. You can choose to put plus c. So for instance, okay, example, integration of negative x squared dx will give you this plus c, followed by this one will give you x squared over 2. You're going to add another constant. The constant for this and the constant for this may not be the same, so you got to use a different letter. Okay, so I will choose the next letter D. Okay, so this results in this. Okay. Okay. However, what if you are very skilled already? You decide not to split it up like that. Okay. You could then be looking at this is 3. Okay, writing in this manner, whereby you just have one constant c at the back. Okay, so you integrate this, you get this, integrate this, you get this, then just plus c. So this plus c here is actually this plus c and this plus c. Okay, so I'm not concerned about the value of the constant. That's not what we're trying to find at this juncture. Okay, so the constant is just something that needs to be there. Okay, to make the integration true. Alright, so anyway, simplified form is this. Okay, but if you're going from this step to this step, you can do f lah. Okay, another constant f. If you're going from here to here. Understand what I'm saying? Okay. Why is it that I don't choose E? Because after D is E, right? Yes, E is an exponential number. Please do not choose E. Okay? What other letters should you be avoiding other than E? O. Yes, great. Okay, because O looks like 0. Right? Next, part B. As I mentioned, we do not have a product rule. So we are integrating x plus 1 times x plus 2 bracket then dx. Okay, so you have to expand this out in order to solve it. There is no other choice. Such that we have this here. So the integration of x squared plus 3x plus 2 with respect to x will be giving you power plus 1. So x cubed over 3 plus 3x squared over 2 plus 2x plus c. Okay. Likewise, in part C, there is no quotient rule. Have to simplify this in this kind of manner. Okay. Then, using our rules, integrate 2 will give us 2x. Integrate 3x to the power negative 2 will give us 3x to the power negative 1 over negative 1 plus c. to integrate 3x squared plus 2 over cube root of x. So same thing applies as for part C. Split it out. Okay, simplify it. Get 9x 8 over 3 over 8 plus 6x 2 over 3 over 2. 6, 3. Okay, we will be getting this. Okay, any questions? So let's look at question 4a in your exercise 16.1. I want us to think about what do you think the integration of e squared is going to be? What is the answer? Huh? So Joseph said e squared x plus c. Why is it e squared x plus c? Why not like that though? Huh? We're integrating with respect to x. Anyone thinks about it in this manner? No? Okay, good. Alright, so I hope you recognize that e squared is a constant number. So it's no different from a number 7, number 8, number -2. Okay, so therefore, it should be e squared x plus c, yeah? Okay? Then what about integration of 2x ln 3 with respect to x? What will this give us? Shamin, can you tell me what is the integration of 2x ln 3? Shamin, what would it be? rest of you give it a try as well. How to integrate 2x ln 3? Sorry, say again. How do you get that? Can you tell me the steps? Bring the 2 ln 3 out. Then integrate x. Is it? Okay. Then you will get x squared ln 3. So quickly. What's the integration of x? X squared over 2. That's all. Then x squared ln 3 plus c. Okay. Wait, do you agree? Don't agree? Then what do you think the answer will be? What do you think? What do you think? Amanda, what do you think? Do you agree with this answer? Yes? Okay, Alia, what do you think? Agree? You agree? Yes, wait now. Wait now. Sorry, wait. X squared ln 3. Yeah, that's here. So you think the answer is just x squared ln 3 plus c. That's the answer, isn't it? Okay, answer, what do you think? You agree with this answer? Yes? Anybody disagree with this answer? No? Okay, so do recognize that this is 2x ln 3. It is 2 times x times ln 3. So we can bring the ln 3 to the front. So 2 ln 3 x is what we're looking at integrating. 2 ln 3 is just a number. Okay, so what Charmaine gave is correct. We should be getting x squared ln 3 plus c. Okay, just that in our usual writing, when we have ln, we don't usually write it as 2 ln 3x. Because number one, it is confusing. 3x, if I write it side by side like that, it's as though x is part of the logarithm function. If I want to write it in 2 ln 3 times x kind of manner, we should have brackets. So in writing, okay, we usually put the functions at the back, be it whether there's any algebra or not. Okay, so ln 3 is a function value itself. Okay. Next, I want to integrate 2ex with respect to x. So likewise, 2e is a constant number. We are looking at integration of x. So x squared over 2 plus c. Answer will become ex squared plus c. Okay? I'll go back a little. Okay, I have touched on try 2, 3, and 4 already. I've not yet looked at try 1. So in try 1, right, we are trying to address how integration is actually the reverse of differentiation. Okay, so in part I, we are given that y is equals to x times x squared plus 9. We want to show that dy over dx can be written in a certain form given in your textbook. This is on page 95. Okay, and we want to state the value of a. So we want it expressed in this manner. State value of a. So in this case, question asks to differentiate. So differentiation in this case, we will use our product rule. Or of course, you could also choose to expand it and then do your usual differentiation. It's up to you. So keep x, differentiate x squared plus 9 is 2x. Keep right, differentiate left. We will get 3x squared plus 9. But the question has it in a certain form, so we have a times x squared plus 3. So we get 3 bracket x squared plus 3, okay, as our answer, and therefore a is equals to 3. Okay, Joseph, this is important. Please wake up. Alright, so after we have done the differentiation, my objective over here is to address part 2. Okay, we want to hence find the integration of 3 bracket x squared plus 3 dx. We know very well that with our power rule that we have already learned, okay, we can actually go about integrating this, okay, in another manner that doesn't require, hence doesn't require our part I's answer. Okay, so let's just do that integration, okay, so that later on we can check our answer. So we are looking at integrating 3x squared plus 9. Our answer at the end should be a x cubed plus 9x plus c. Okay, so this is like an otherwise method. Right? But to keep to the essence of the question, which is to use hence, how do we go about doing that? Okay? We learned that integration is the opposite of differentiation. Seeing in part I, when we differentiate y, I'm getting 3x squared plus 3. Okay, 3 bracket x squared plus 3, which is exactly the same thing as what we have here. So when I want to integrate 3x squared plus 3, with integration as the opposite of differentiation, I should be going back to get y itself. You understand what I'm saying? Okay, so I will be getting x bracket x squared plus 9. However, we know that in integration, when you get back y, there are many forms of y that I can have because of the constant value, so I should have a plus c at the end. So this is how I actually make use of the hence idea. From the differentiation, I get back the original function. This is a very important concept, okay? Especially when we look at applications itself. Right? Are these two the same? It is, because if you expand this, we do get back the same thing. Okay? But it's not all the time that I will have the skill in being able to integrate in the otherwise method. Okay? So giving another example. exercise 16.1 question 2. Looking at part 2 itself, we want to hence find the integration of this. At this point, based on the skills that we have learned, we are not able to integrate this at all. Okay? Because what we learned about the power rule is strictly only for power x to the power of n. I cannot have anything inside brackets. Okay? So we're looking at integration x power n such that I get n plus 1 over n plus 1 plus c. This is what we have learned so far regarding integration. Okay, so therefore I will not be able to solve this. Right? So I need to look at part I. We are asked to show this. Okay, so going about differentiating, what's given in the question? I will use my quotient rule. Keep bottom, differentiate top, minus keep top, differentiate bottom, bottom squared. So I showed it. Okay. But the problem here is, if I try to use the skill that I learned earlier on in the question, I saw that the integration part was exactly the same as what we got in part I. But in this case, we see that what we have differentiated, what we have arrived at, is only a 1 over 2x plus 1 squared. While in part 2, we are having a 2 over 2x plus 1 bracket squared. So we have this additional 2 over here. How do we go about addressing that? Okay, so that's where we know that 2 itself is a constant number. It is as good as thinking as though it is a 2 times 1 over the fraction 1 over 2x plus 1 squared dx. So I see that over here, this thing inside is exactly the same as this. Okay, therefore I have 2. Integration of this leads me back to the original function, x over 2x plus 1 plus c. So we have 2x over 2x plus 1. 2c, you can re-express it as a d, that's fine as well. Okay? So this is where you learn how to integrate as a reverse of differentiation. Okay? Okay, so far we have covered 3 skills, yeah? Alright, integration of power rule. Okay, then after if I have a constant, I can take that out and then integrate as per normal. And also what I just covered is integration as a reverse of differentiation. So you may be asked, okay, to differentiate first, then after that use the integration to integrate something based on your answer in part I. Okay, next thing that I will cover is actually to learn how to integrate ax plus b to the power of n dx. Okay, which actually is what we are saying over here. Okay, in other words, 2x plus 1 to the power of negative 2. Okay, there is a rule for this, and that is actually rather similar to this here. So we have our ax plus b, power always plus 1. Okay, bring down the coefficient of x, which is a, then plus c. Okay, sorry, and also n plus 1. Okay. Alright, so let's look at some examples. I want to integrate 2x minus 9 to the power of 4. So we will have 2x minus 9 to the power of 5 over 5 times 2 plus c. So it will be 2x minus 9 to the power of 5 over 10 plus c. Okay, questions? Right? Since we're at this, okay, maybe we could also check the answer for part 2 earlier on using this rule itself. Okay, so what we would have gotten, let me just write it here. So if we done an otherwise method, and it's not all the time that they allow an otherwise method, by the way. Usually, we don't recommend you using otherwise method. Okay, so we understand that the 2 can still be taken out. Okay, so we are looking at the integration of 2x plus 1 to the power of negative 2. Using that new rule, we are looking at power plus 1, so it becomes negative 1, over power, bring it down, coefficient, bring it down, plus c. Cancel, cancel, negative 1 over 2x plus 1 plus c. Okay, now why is it different? Okay, why is our answer here different from answer here? Okay, the answer actually both means the same thing. The reason is actually due to the constant itself. Okay, I could show you very quickly how is it that they are the same. Just to show it to you. The reason is because 2x over 2x plus 1, if I were to do my long division, okay, your partial fractions, so we have 2x over 2x plus 1 to be 1 minus 1 over 2x plus 1. Okay, so essentially, this refers to a 1 minus 1 over 2x plus 1 plus d, which is negative 2x plus 1 plus 1 plus d. So this plus 1 plus d refers to the constant here, c. Okay, so the constant values are different. Okay. Questions? Okay. I erase this try 6 part A. Yeah? Integrate 1 over 3x minus 1 cubed dx. So, same as earlier, change it to a power of -3, power plus 1. And we have -1/6 3x minus 2 square plus c. Okay. Next, for try 6 part C, we want to integrate the square root of 5 minus x over 3. So bring down the power, 3/2. Coefficient of x in this case is -1/3. Okay, cancels out. And we have -2 bracket 5 minus x over 3 to the power 3/2 plus c. Questions? Okay. Next, we level up a bit. Let's look at question 11 in your exercise 16.1. We want to integrate x squared plus 2x over x squared plus 2x plus 1. Okay. In fact, all the questions in 11, it doesn't fit in any of the skills that we have acquired so far. Okay. So we have to make it fit. In this case, we definitely shouldn't be doing reverse of differentiation because we don't even know what does the function look like in the first place. Okay, so when you want to use reverse of differentiation, usually they will tell you what is the original function to begin with. Okay, so this is usually not an option. Okay, so what we need to do is to be able to observe that our numerator and denominator can be factorized. Okay, it isn't helpful in case you are thinking of doing this, to split it up into two different fractions. Even if you do this, not helpful at all. because you can't cancel anything out, okay, that's illegal. So therefore, this is not helpful. All we got to do is factorize the numerator, factorize the denominator. X squared plus 2x plus 1 actually gives you a x plus 1 squared. Hang on, did I miss out anything here? Oh. If you were to factorize it in this manner, okay, which is a common process, okay, but then you realize that it still brings you nowhere. Right or not? Okay, it doesn't bring you anywhere because you cannot cancel anything, right? You can't use any of your power rule, you can't combine anything at all. Then how to go about doing this? Okay, instead of factorizing our numerator in this manner, okay, let's think about it as our completing the square. So x squared plus 2x is our plus 0. Complete the square. We have, because x squared plus 2x, down here also x squared plus 2x. So x plus 2 over 2 square minus 2 over 2 square plus 0. We have this. Okay, and this really helps a lot because I can split up the fraction for it to look like this. Okay, then we are looking at integrating 1 minus x plus 1 to the power negative 2 dx. Yep. Sorry, say again, I hear your last words. Can you use partial fraction? I'm not teaching a partial fraction now. Yeah. I'm not trying to teach a partial fraction method now. Yeah, so when do we touch on that? Our partial fraction method only goes into your logarithms. Yeah, I don't. Okay, I've not tried it. I think it might be possible. Okay, yeah. Have you tried it? What do you get? Same thing. Yeah. You could lah, but let's not go into that part first. Okay. Yeah, so I'm now trying to introduce one of the ways that you can think about that. Okay. Okay, so we get integration of 1 minus x plus 1 to the power negative 2 dx. Then we will have our x minus x plus 1 to the power negative 1 over negative 1 plus 1 plus c. So we have x plus 1 over x plus 1 plus c. Okay, questions? Alright, maybe for part B, let's just skip that part first, okay? So in future. Alright, I want us to take a look at part C. Okay, we want to integrate 3a squared bracket square root x plus cube root of x with respect to x. A is a constant, so we can move that out of the integral and look at integrating x power half plus x power 1/3 followed by a dx. So that leaves us with x to the power 3 over 2 plus 4/3, 4/3 plus C. X 3/2/3 plus 3x 4/3/4 plus C. Okay. You can consider simplifying this further if you want to expand it, or leave it in this manner is perfectly fine as well. Questions? Alright. I think I'll just end here today. Okay. Next lesson itself, I will go into some applications. That means all your problem sums, knowing your parallel, your normal, okay, your straight lines, and then after that your rate of change, all that kind of questions. Okay. So it's a reverse process that we're looking at.